Hello, so thank you very much for joining us in part one of this discussion. In part one, I just tried to show you, we started in a very simple way to show you what econometrics is all about, and basically we use regression to do much of that. Now I try to explain the basic concepts of regression, the model in terms of dependent and independent variable. I also tried to explain what core and non-core variable means in your analysis. And then we went into the practical and we looked at how to bring your data into EViews. I'm sure you have mastered that. We also looked at how to edit your data. And then I quickly showed you how to do simple regression and also multiple regression. They are simple things to do. Today we will be looking at basically the discussion on multiple regression with log. In some cases, you will need to log your variable. I'll explain that as we go into the slide. And then you may also need to use your dummy. I will explain clearly. If you understand the concept of dummy variable in regression, you can use it to do a lot of things, okay? And if you look at our outline for yesterday, for the part one, I had wanted to treat something we'll call causality test in the part three, but I'm thinking we'll need more time there to do something a little bit technical. Some of you know we'll call it unit root test. So we'll do it in part three. But I decided to bring up the issue of causality tests in our discussion in this part two, so that we can have more time to look at that in the other aspect of part three. So thank you very much for joining in this particular connect. So we're going to go straight to the discussion. And if you have your data, bring your data to your EViews again. That is exactly what I'm going to show you on the slide. We'll bring our data and we continue from there. All right. But before that, I'll show you the slide just to explain a little bit what we're going to do, and then we'll get into the EViews. Thank you very much for joining. All right. Cheers. So, like I explained, you're welcome to this part two of our discussion. And in this part two, our interest is clear. For those of you who have not seen part one, please refer back to the link on this video. I've shared the link of part one we treated so that you can start from there. If you take it gradually, you will get to where you are going to. Okay, please don't skip anyone. Now, let's get to the contents. I mentioned to you that I had to do a little adjustment. That in part one, we saw how to bring data to EViews, how to modify your variable or add a new variable, how to do simple regression and multiple regression. Now you can agree with me that these things are quite simple. It depends on who is at the steering. And I think God has given me that grace to guide you. So previously, this causality test was supposed to be treated in part three, but I brought it up here so that we can have a little more time to look at what happens here. Okay, so today in this part two, we're going to look at the multiple regression with log variables. And you still remember what our model looks like. So let's go straight to EViews without taking much of our time. You still bring up your data. This is the data we are using. Okay, and then we go to EViews. You open EViews and take it off from there. People prefer to use a lot of shortcuts in terms of doing things. So I showed you how to do the longer approach in bringing your data and how to use the shortcut. So I think you may prefer that I use the shortcut to do it. So now I remove this and I want to bring in my data and we will take it off from there. Now to bring in my data, you open your data, the Excel file. Because we are trying to treat log like indicated in our content here, we want to look at log. I want to say categorically that you can only log time series in this context. You will not be logging cross-sectional data like we have here, because cross-sectional, we just collected it today, except for data, the fact that they are not. Basically, why do we log? We log to actually shrink the weight of this data to enhance numerical accuracy. Okay, if you want to estimate this income and you are using, if I want to calculate this manually, and you are to sum up this and I'm to sum up this manually, I'll be more accurate than you. You may run into errors. So logging helps us to reduce the weight of the data to enhance accuracy in estimation. So if you look at GDP, GDP is a bit large. FDI, foreign direct investment, is large. Exchange rate, since it's small, we may not need to log it. You may also wish to log it for reasons best known to you. If I log all my variables, it becomes log linear model. If I log only some and leave some, it becomes semi-logged model. So let me quickly copy my data, the time series part, and go to what we are looking at. So I copied it with dummy this time around, because we will be treating dummy as well as stated here. So let's open the EViews. I right click and dropped paste as work file, and that is it. I click finish. So that brings me to, I don't want to link it to the source. That brings me to my worksheets. Okay, my work file, like I described as the carpenter's table for his job for the day. So now I have all of this here. Remember simple regression, you go to quick. I'm sure you are with me now. You go to quick, you click estimate equation, and then you type in your variable. Alternatively, like I mentioned earlier, if GDP is my dependent variable, I click GDP and hold Control key and click any other one I want to join in the model, and then open it. Right click on it and click open as equation. It opens the model for me, but in most cases it will put your C at the end. I prefer my C to come immediately after the dependent variable. Is a preference. Even if you leave it there, it doesn't distort the analysis or the estimation. Okay, so the next I would do is to click OK. Now, for your information, there are a lot of methods that can be used here. So many methods in analysis that can be used here, but for a start, a beginner, let's keep it at this level. This level is actually what we call ordinary least square method. If you read literature, you will find justification to use other methods. So let's continue here, and then I click OK. It gives me my simple regression. This is the result. Now, like we saw in part 2, this is your dependent variable, and this is independent variable, and it's significant at this point because your p-value, probability value, is less than your alpha. The alpha we are using here is 0.05, which is 5%. So once your p-value is less than your alpha, then you know that the variable is representing is significant. And that means that the coefficient you are seeing here has real value. If it is not significant, whatever is the coefficient is equivalent to 0, statistically speaking. So this has real value, and this real value is the weight that our parameter is the weight it is showing on GDP. So ordinary interpreting, literally, we will say that export has positive impact on GDP because the value here is actually positive. If it's negative, the system will show us negative sign. So export has positive impact on GDP. Further interpretation, we note that a unit increase in export, when you increase export by 1 unit, it will increase GDP by 2.6, approximately 2.6 units. A unit increase. When we say a unit increase, we are not saying +1. If this export is counting in billions in the data we used, or in millions in the data we used, a unit increase means a billion increase or a million increase, depending on the measurement that was used. So when we say unit increase, don't think we're just talking about one currency increase. Okay, it depends on the units you have measured that particular variable. All right, and then let me quickly draw your attention to something important here. This is R square. R square measures the goodness of fit of this model. It's trying to tell us how much this independent variable, if it's more than one variables, are able to explain the movement or the behavior of your GDP. And this R square ranges between 0 and 1. 1 is the maximum. If you get 1 in any model, I can tell you freely that that model is wrong, because it means that it has used up that thing we call error terms or stochastic variable. Remember, I showed you that when we are checking the impact of export on GDP, export definitely is not the only thing affecting GDP. So other variables affecting them are captured by that error terms, and that is why this thing will hardly become equal to 1. But if I add that error term, which is a wrong model, this will become 1. Let me show you. Estimate. Anytime you want to modify your model, you don't go to quick again. So far you have a result here. You click estimate. Okay? And then let me add that error term. What is the error term? See that residual here. I click it. It's not supposed to appear in your model anytime. You are not supposed to include it except you are doing a particular test using that particular residual. So let's click OK. It says it cannot even run it. It's saying there's an error. But I could do another analysis where I use distributed lag and include it, and it will enter, but that will be an error. So it's saying you are trying to do what we call deterministic model. Deterministic model, which is mathematical, but we are looking at statistical model. Statistical model allows room for probability, chances that this does not explain everything. But if you get a very low R square, it suggests that the result is not quite good. The independent variables are not enough to explain the behavior of the dependent variables. There are other tests that are here, but because of the way we are going, I'm not going to discuss them here. I will include a link in this video, and that link discussed this method and how to interpret them. Okay? Maybe once you check that link, you'll be able to find it. Okay, so this is basically a simple regression. Now, I can decide to log it. There are two ways I could log my model. I can log my model by putting log in front of each of the variable. What is log? You know the spelling, L-O-G hyphen. This is natural log, and that is based, log to base 10. All right, so then I'll log this too. Now I've logged both my dependent and independent. If I click OK, that becomes log linear model. You see, there is log here, there is log here. Now you see my C, the constant, has behaved better. It's now significant. Okay, it's now significant. Now, but when you interpret a logged model this way, you need to be careful. We will no longer be saying a unit increase. You see, there is still positive here. So this will be saying that export has positive impact on GDP because a percentage increase in exports, because you have logged it, the language changes. A percentage increase in exports will increase GDP by 0.9% approximately. All right, so you become careful. So this is log linear because I've logged all the variables. Now I could remove the log on exports on GDP. Okay, let me remove on exports. Once there is one variable that is not logged, it becomes semi, because it's no longer full. Semi-logged model. Now we see Export is not logged. GDP is logged. So this is semi-logged model. All right. So this is also fine, but when you interpret, you become careful to read that a unit increase in this will increase this by certain percentage. And that is why those of you who know how to do standard number, you discover that this is 0.00 something. Okay? Beautiful. Now, on the other way, we can also decide to keep our GDP as not logged and log exports. But whatever you are doing, it may be nice you look at literature to justify it. You don't just begin to log arbitrarily. Okay? So now you see that a unit increase, a percentage increase in this will increase this by this unit. So this unit is higher in this context now. A percentage increase here will increase GDP by this unit. So that's basically all about log model. Okay? I can decide to include other variables and make it multiple and log them. Okay? Now let me include log of what? Imports. And then I click OK. This is full logged model. Okay? Or we call log linear model, because what we are also doing is a linear model. All right, so this is logged model. Now you have known this. Let me show you another approach to it. Instead of going this way, permit me to close this result. If you like the result, remember I said you copy it and paste in your Word document. Now, instead of going that way, I may decide to use something here. Okay, I may decide to use C here. Okay, on this work file, if I save it, it becomes the name of the title, so it's untitled here. On this work file, there is object here. I click on object and click generate series. Generate series here, I could say ln, all right, GDP is equal to log of GDP. So I am generating a variable called ln GDP, so that when I'm doing my analysis, you'll not be seeing log in brackets. I can use any other thing to symbolize, to represent it, you know. But most people prefer to put len, so that you easily know that that variable has been logged. Now I click OK. It now gives me that len here. You see it here? All right. So on the same object, I will generate len exports. Remember, you won't allow space in the variable name. Is equal to log of export. Okay? Log of exports. Then I'll click OK. Then I can also generate log of import. Log of import. Then that is log of import. I hope you are following. Be repeating what I'm doing. That's how to learn. Monkey see, monkey do, right? Great. So now I've generated that. So when I want to do my estimation, I will now do my estimation based on these logged variables. I clicked GDP first, like I mentioned to you, and I hold my control key, click export, len of export, len of GDP, len of import. Then ask the system to open it, ask the system to open it as equation. Okay? The system will open as equation. Now, permit me to put my C, the usual place. And so, if I click OK, in this case, it gives me the log linear model, but it's not carrying log as we know it. But I've used a symbol ln to represent log, and this is exactly the result we got earlier. Okay? So this is basically how to do your logged model. The other one is dummy. Now, let me show you give you a little understanding about dummy. When we say dummy, dummy is not something very strange. It's like you are deciding to represent something with something, and that thing you are representing doesn't have a weight of its own. Okay? It doesn't have a weight of its own. You are only using something to represent it. Okay? Good. So dummy is not a continuous variable. When we say continuous variable, we are thinking about 1, 2, 3, 4 to infinity. Dummy is what we call category. Category 1, 2, 3. Sometimes it's called indicator variable or qualitative variable. Qualitative variables are those variables that are like colors, male, female, colors, black and white. You can't say black is bigger than white or something in that context. So you now assign a number to these qualities, and that number represents it. It's like making it that quality. You are now quantifying it in terms of number. All right. So like yes and no, I can decide to say that my yes is 1 and no is 0. Male and female, I can decide to say male is 0, female is 1. By the way, some people keep wondering, if I'm the one doing analysis, for instance, and I want to check the impact of being a male-headed household head, a female-headed household head, the impact of female-headed household head, families that are headed by female, on the poverty of households. If that is my interest is on the female headed, I will assign 1 to female. But if my interest is on male headed, I will assign 1 to male and assign 0 to female. Or maybe there is a policy and intervention government has done, and you want to find out pre or post that intervention, did it have any significant impact or not? And that is why I'm going to use one policy that federal government of Nigeria had done before, and we use it and draw an issue. We use it and draw an issue to be able to draw policy. Okay? Good. So now what we will do is, okay, for instance here I've shown you how to assign this. It's a male 1, female 0. But I can also say female 1, male 0, depending on my key interest in that research. Okay? Depending on my key interest in that research. So then, or there are households I've studied, and I want to check these households, whether they are poor or rich, and I've found a way of classifying households that are poor or rich, and then I can use that dummy to say for the poor household, maybe rich household, let 1 represent rich household, those who are above poverty line, and let 0 represent those who are under poverty line, and I can use it to do certain analysis. But let me show you example we're going to use in this context. We're going to use what federal government of Nigeria some years back, called Structural Adjustment Program, around the year 1986 or thereabouts. Structural Adjustment Program, and they brought in some policies to liberalize the economy. So we may want to study before this adjustment program and after, was there any significant impact? You see our dummy here. It's a post-SAP era and pre-SAP era. If my interest is to find out whether post-SAP era has impact on GDP, this is fine. But if my interest is to find whether pre-SAP era had interest, I will now make pre-SAP to become 1. Now let's get to that data set. The data set we have here, you see the dummy, we created this dummy based on the fact that we are looking at pre and post. You see, I've assigned 0 from 1970 here, and it's running until somewhere 1985, just before the SAP was introduced. So 1986, when SAP was introduced, down to where the data stopped, 2012, that becomes the the posts. So I'm going to use it to do this analysis, and it's a very simple thing. Let's get to that EView. You see, these are our results. I can decide to work on it. I'll go to estimate and add dummy here. It's a simple thing. I add dummy here and then click OK, and it gives me a result. The result is showing that this dummy is not significant. Okay, it's not significant in this particular model. Because it's not significant, this is equivalent to 0. So people will say there is a negative but non-significant impact. For goodness sake, that is not correct. If it is not significant, this value is statistically the same thing as 0. So you cannot begin to say there is a negative relationship but not significant. Okay, if you say it, it's just like saying that 0 is negative, which is not correct. So once we establish that it's not significant, this is statistically equal to 0. And because the impact is 0, it shows that post-SAP error in our study did not have any significant impact on GDP here. Okay? So you can use it to do different things. Male and female in the class, you are doing analysis. You want to find whether gender is important or not. You can assign this dummy the way you want it to happen. Okay, so that's basically about dummy. Now, let's get to the other gist, which has to do with, okay, if you look at what we are following, our outline here, so we've been able to do multiple regression with log variables. I'm sure you can do that now on your own, when those variables are very weighty. Another variable you cannot log is when there is negative in one of the data. If, for instance, somebody is looking at economic growth, and at certain year, the country had negative economic growth, you won't be able to log that variable. Okay? So you run it as it is in terms of units. Now, for multiple dummy, variable, multiple regression with dummy, we have treated it. This name sounds big, but it's beautiful. We have seen it. If there's something government is doing and they want to check whether military era and democratic era has impact on economic growth, I can just use that kind of dummy to separate both era. At certain point we had military, at certain point we had democracy, it had military, we had democracy. So that merging can also be used in that way. It must not be, demarcated at certain point. Dummy behavior, what am I trying to explain? He said this 1 and 0. Fortunately, this policy error had 2 periods. But it's possible that at certain year there is 1, at certain year there is 0, and they are mixed up. It's still fine in your analysis. Regression with dummy will also show you that particular result. So we'll be concluding with causality tests, but just for you to understand what that is all about. Now, you see the way we have been using our variable. Okay, say this result. Somebody may want to ask a question. Each time, is it possible that behavior of export is the one causing variation in GDP? Oh, you didn't get me. Let me take it a bit simpler. You are a lecturer like I am, by God's grace, and then you have students in your class. And each time a particular girl gets up to excuse herself for something, a boy also gets up in that class to excuse himself. Each time the boy is coming late, that girl is also coming late to the class. Now, somebody may want to do a study to find out who is causing who to behave the way the person is behaving. And that is what we call causality tests. We want to test what is causing what to vary. You may test it and discover that there was actually no causality, that thing has been happening by chance. You may also test it and discover that there was one-way causality. In other words, maybe the young man is the one actually influencing the girl. Maybe the girl got up first, but giving a signal from the young man, so she will get up first. So you do that analysis. If it is only one person influencing the behavior of the other person, we call it unidirectional causality. But if two of them are influencing themselves, we call it bidirectional causality. And to estimate it, the model is simple. This is the kind of model you estimate. The one you want to check, you put it there, and this looks a bit mathematical. Just calm down. I will explain. This one you want to explain, okay? You are trying to check whether M is the one causing this GDP to behave. And to do it, you want to use M in this year, that is MI. And you want to use M last year, M last 2 years, M last 3 years. That is what this I here is showing. M for this year, if this year is 0, for instance, or if this year is 1, you say at time 1, that is current year. Then you drag this I up to N here, that is I running from 1 to N. If the N we are considering is 5 years interval, you want to check in the last 5 years, can we say that the variation in M is the one causing P? And that is what this sigma here represents. Okay, so in the real equation, we are going to put lag here. Okay, and that will get us what this is all about. I will explain it more when we discuss autoregressive model in part 3 rather. And then to also get that equation proper, we will include this GDP as an independent variable, but not in the current year. We will shift a year away from the current year. And that is why this I and this J are not the same. This J could be T minus 1, giving us that particular, maybe this current year. So we are looking at last year and last 2 years. We will not put exactly this year on itself because this is like on the current year. All right, so let's keep it there and let me show you how that analysis is done. It's a very simple thing. Do you want me to continue with the linear? Okay, let's continue with linear. All right, let's leave linear. Let me close this. Let's use the one we did not log. To do that test is very, very simple. You come here and click on quick. So this helps you to identify variables that you could say are policy instruments that could be influencing something. So somebody may want to do causality, and based on the result of the causality, now start doing impact to see whether there is impact in that study. So you click quick, click it on your own system now. You have the software, click quick. All right, beautiful. Then you see somewhere group statistics. You click on group statistics. The last thing there in this particular version of EViews is Granger causality tests. Okay, if you design your own method of analysis, you can name it after yourself. Those who have done it before us should take the credit. So we click on this Granger causality tests, and then we bring in the variables we want to check. If you understood what I had explained, you do it in pairs. GDP, all right, and then I'll put import. The system will generate other things on its own. These are the two I want to run. I click OK. It will ask me, this is my import. What is the lag length I want for it? How much years back do I want to check for each of the independent variables? This is giving me like 2 years at default. If it's fine by me for whatever reasons, I keep it at default. If it is not fine, I will redefine it. I can make it 3 or 4 depending on what I want to do. But you need to keep an eye on your data length. If your data length is small, you don't take high lag length. Okay? So let's click OK and see what result it gives us. This is very beautiful. It gives us a very good result. Okay? Now look at this result. The null hypothesis is stated here. The null hypothesis states that import does not Granger cause GDP, and GDP does not Granger cause import. if we find reason to reject this null hypothesis, we accept the alternative. Now, this is our F statistics. This is our probability value that we're going to use. For some of you who are not very, very mathematically inclined, this may be a bit confusing. But let me pull up Excel and show you what it means. Just chill, right? Beautiful. Now, this is Excel. What that thing actually means, okay? What that thing actually means is that you have, let me do it in here, in our slides, so we'll get it better. Or let's keep the slide. What this thing actually means is that you have this value 8. Okay, let me type it here. You have a value called 8, 0.8. But this 0.8, you can't put your point there until you drag it back to 5. You see this, our 8? You can't just write the 8. There are 0, 0 in front of this 8. So that is telling you, you drag it back. This your minus here is showing you drag it back. So that will mean if I jump the 0, the 8 by one step, it becomes 1. I'm counting up to 5. I'll put another 0. That's 2, 3, 4. So there are 3 points. Is that 3? Okay. Okay, there are 4 points, 4 zeros before the 8. So this is, if we now put 0 point here, 0, then we have 1, 2, 3, 4, 5. So that particular first one, this is actually the value it's giving you. So can you do this next one now? You have 5. You have 5 there, right? So you take it back how many steps? Some of these are mathematics we treated in primary school, for goodness sake. But chill. It's fine. It's good you learn it now. You know, Igbo adage said, "Osita ademma ode barabo." If you learn it today, it is still better. All right. So we'll take it back. 1, 2, 3, 4, 5, 6, 7, 8. Let's count. Let's put dots here and count. So 1, 2, 3, 4, 5, 6, 7, 8. So is that okay? Now, these values here, are they less than 5% or not? Remember our 5%? Your 5% actually means, if I put equal sign here, 5 divided by 100. Okay? It gives me this. This is 5%. So these values, are they less than 5%? Of course they are less than 5%. Therefore, get back to this result. This result is showing that these two variables are significant, because when your probability value is less than 5%, you reject your null hypothesis. I will take it again. When your probability value is less than 5%, you reject your null hypothesis. And the system has given us beautiful null hypothesis here. The null hypothesis states there is no Granger causality between two of them. Okay, so, but since this has shown us that we'll reject this, if we reject it, we will conclude that there is Granger causality. So export is Granger causing GDP. GDP is Granger causing export. In other words, that takes us to the discussion on that causality. What do we see? Is it bilateral or unilateral? If you fail this one, you need to repeat this class. It is basically bilateral because it is two-way directional. Okay? They cause each other. Like the example I cited, it's possible the boy is influencing the girl and the girl is influencing the boy. Now I've shown you how to do this. I hope I've influenced you, unilaterally to begin to do well in your future analysis. By the way, this is where we are going to stop our discussion for today, so that we have space to do more things tomorrow. If you've not subscribed to this channel, please subscribe, and thank you very much for giving time to this discussion. As you learn this more, your hand will get stronger in data analysis. Thank you, and watch out for part 3. Cheers.